All right, 7.1, we're looking at operations with monomials. So we're going to learn how to add, subtract, multiply, and divide. Okay, and before we learn how to do all that stuff, we might need to know what a monomial is. So a monomial can be a number, a variable, or a product of a number and variables. Okay, monomial, mono means one, so we say this is one term. Okay, so it could be like 3, that's a monomial. X is a monomial. 3x is a monomial. 27x squared y to the third is a monomial. Because there's no addition or subtraction. It's just numbers and variables, and they can be multiplied. And then monomials with the same variables and exponents are what we call like terms. Okay, so they have to have the same variables and the same exponents. All right, so adding and subtracting, when we're adding and subtracting monomials, all we're going to do is combine like terms. Okay, so we've done this before when we have things with x's, all right, and now it can be any variable. All right, so here's our first example, 19x minus 24x. Okay, so same variable, so we can put them together. 19 minus 24 is negative 5, so this is negative 5x. All right, negative 19k squared plus 2k squared. Same variable, same exponent, so we can put them together. Negative 19 plus 2 is negative 17k squared. All right. Same idea here. Even though we have 3 variables, r squared, s to the third, t, my variables match, so I can just add or subtract whatever it's telling me to do. Negative 12 plus 4 would be negative 8, and then all of my variables and exponents stay the same. All right, and we could have something like number 11, where we have v squared and then v, so I can put together the things that are the same. So 11v squared plus 2v squared would give me 13v squared. All right, and then 7v minus 32v would give me negative 25v. And then that would be my final answer. I cannot put together v squared and v because they don't have the same exponent. All right, so that was add and subtract. Now we're going to move to multiplying, okay? When we multiply monomials, we use something called the product rule. And what the product rule says that if I multiply these two things, I am going to add the exponents. Okay, so when I multiply two monomials, the variable stays the same, and I add the two exponents together. So x to the fourth times x squared is x to the 4 plus 2, or x to the 6th. Okay, here we have a to the fourth times a. It's important to remember that we never write it, but this is a to the first power. So this is a to the 4 plus 1, which is a to the 5th power. Okay, then when we throw coefficients, remember the number in front of a variable is a coefficient. Okay, we multiply the coefficients like normal, and then we add the exponents. So here, 3x cubed times 7x squared. So I'm going to multiply 3 times 7. That's going to give me 21. And then for the exponents, I'm going to add them together. So 3 plus 2 is 5. Okay, so multiply the coefficients, but add the exponents. All right, so I'll do another example here. Negative 8 times 2 would give me negative 16. M to the 7th times m to the 3rd would be m to the 10th power. Okay, multiply the coefficients, add the exponents. You can do the same thing when we have multiple variables. You're just going to do each variable separately. So I like to always start with my coefficients. Negative 6 times positive 4 would be negative 24, all right? Then when I combine my a's, I have a to the first and a to the third. So 1 plus 3 would give me a to the fourth. And then I'm going to do the b's. So I have b squared times b to the sixth. That would be b to the eighth. And that would be my final answer there. Negative 24 a to the fourth, b to the eighth. And then last thing we're going to look at is dividing. And so for dividing, we have a rule. Multiplication and division are opposites of each other, which means that when we divide, we're going to do the opposite with the exponents. So we're going to subtract the exponents. Okay, so x to the fifth divided by x to the third is equal to the x to the 5 minus 3, or x squared. Okay, k to the 12th divided by k squared, that's equal to k to the 12 minus 2, which is k to the 10th power. Okay, the rule doesn't change when we have multiple variables. We just do them each separately. So I kind of like to think of this as like two separate problems. All right, so a to the 6th divided by a squared. 6 minus 2 is 4, so that's going to be a to the 4th. And then b to the 4th over b to the 3rd. That is going to give me b to the 1st, and we don't have to write first power, so we can just leave it as a to the 4th b. All right, just like our division or multiplication rule, we can do the same thing with division where we put coefficients in, and we are going to divide the coefficients like normal, okay? So 6 divided by 2 is 3. X to the 4th over x to the 3rd, 4 minus 3 is 1, so that's just x. So that would be equal to 3x. All right, 14 divided by 7 is 2. R squared divided by r is r, because 2 minus 1 is 1. And s squared divided by s is s. Okay. Now, sometimes our fractions don't simplify or don't come out to like whole numbers when we do division. So like 4 divided by 8 is not a whole number answer. So when that happens, we're just going to simplify the fraction. All right, and then my exponent or my variable is going to go on top. So n to the 5th divided by n is n to the 4th. So I'm going to write this as 1n to the 4th over 2. You also might see it written as 1/2 n to the 4th. For now, I want us to stay away from this because we're going to get into some other rules later that if you're in the habit of writing it like this, it'll make your life easier.